Hello, Mr. McHugh. Welcome 108 students to section 10.6, page 2. Working on more problems with logs, but this time we're going to deal with base E, natural logs. Okay, so question is, how can we handle these? These ones, you need to take the natural log on both sides. Okay, so I'd recommend you go that way here. So first step was take the natural log on both sides. Now how are you going to remember that? First you see E, you remember that's 2.71. It kicks off natural logs in your head, and you see that the variable x that you need to solve is up in the exponent. So take the natural log on both sides of the equation. Okay, now that you've done that, then just like how I did the last example, the main solution, you've got the exponent, and that comes down by the power rule down to the front, and that's the key step that allows you to solve these problems. That exponent gets taken down times the natural log of E equals natural log of 40. Okay, now from here, what is the natural log of E? Okay, so we're going to take a minute here, and I'm surprised the book doesn't make a bigger deal with this here as like a rule or property or whatever, but take the natural log of E, transform it, aka natural log is log base E and result E. So hold on a second here, I want to get some color going here. So here we go. I'm going to make this one, the result E is going to be in green, and I want you to see that is going to be kept here in this green. And when I converted natural log into log, L-O-G, what was the base? E. Red E, I'll call it. Okay, now, then what happens is, what happens when you have a log, L-O-G, of the base and the result are the same? You got to go back to section 10.3, objective 4, and remember then, whenever you have a log of the base and the same result, that turns out to be equal to 1. Okay, so you got to go back and do a refresher if that's slipped your mind. So therefore we can conclude that the natural log of result E equals 1, and take that and substitute it right up into our equation. Okay, that's a huge step because, and a lot of us here, you see the proof of it, you just got to remember and say the natural log of result E equals 1. Then that will stick in your brain. Now you're multiplying 1 times 0.03x, and then of course from here we are going to divide both sides of the equation by 0.003. So we've got x equals, take the natural log of 40, get that result from your calculator, divided by 0.03, and boom, there's your answer, 1230. Okay, so that's not too bad. I'm just going to summarize how to solve these problems. You see the variable up in the exponent. You want to think of natural log because you got the special letter E in there. Okay, and use the power rule to bring down that exponent down on front and multiply it by natural log of E, and log of E, natural log of E equals 1. Okay, so a lot of key properties on here, but once you remember them, you should be in pretty good shape. Okay, so now we're going to move on to objective 2. We're going to solve equations with logarithms here. I'm just going to do some summaries here. We're not going to get to any problems till the next page. So transform the equation so that one log appears on one side of the equation. Use the product quotient rules. Okay, so these, you see these rules, and I like to write them up in front, and then we're going to go do some examples with them. You probably have noticed is the book likes to do the examples and then write the guideline steps afterwards. I think it's better to do it the other way around, but it doesn't really matter, whatever works for you. So you're going to isolate a log on one side of the equation, and then we're going to take advantage of whenever you've got the log with the same bases equal, you set the results equal. Okay, and that's what that's use those words over and over again because you remember. Other way, back when I did the first example out of this section here, convert from log into exponential format's another way. Now over here, I just summarized here the log of the base result with the result equals the exponent. Okay, and we've done this way back at the beginning here, but I just guess I want to make sure iteration. If you want to convert this from log into exponential format, bring down the result, it equals the base raised to the exponent. Okay, now what was interesting was at this point I remember telling one of my classes here that if I ever when I write, I say whenever I say, and I think I'm going to do this one of these days, write my own math book. I would write, here's how I would write this rule. You keep hearing me say the words. Imagine if they would use the variable b to represent base, capital R to represent result, equals, I'm going to say capital E, not little e here. Log of the base result with the result equals e. Then you could turn around and transform that and bring down and say the result equals the base raised to the exponent. And I only show that as a way to help you drill these conversions into your head so you remember them. Okay, Mr. McHugh, that's it for now for page 2. We're done with that. Adios to page 2 in the books, and we're going to go ahead and do some examples here on page 3 to show some of these techniques, and you're going to notice that these are good ones to make sure you review because you're going to see them on the quiz and on the test. Okay, so for now, take care, and I will see you for page 3. Okay, bye.